Okay, let's get into it. I want to work through an example problem here involving some stoichiometry. And we have a reaction between a chemical called ammonium sulfate and sodium hydroxide. Um, and the products of that reaction are sodium sulfate, water, and ammonia, which is gaseous. Okay, um, so the question here is, what mass of sodium hydroxide is required to react completely with 15.4 grams of ammonium sulfate? So first thing we need to do is to find the number of moles in 15.4 grams of ammonium sulfate. Okay, so we calculate our molar mass, and the way that I have set that up is by first arranging it so we count the number of atoms of each element in the compound. So we have 2 ions of ammonium, so that means there are 2 nitrogen atoms in this formula. We then look at hydrogen, and we have 4 in a single ion, 4 atoms of hydrogen, but there are 2 ions, so that means we have a total of 8 hydrogen. We have 1 sulfur, and we have 4 oxygen. Okay, so then I replace the chemical symbols with the molar masses of each element. So the molar mass of nitrogen is 14.01 grams per mole. The molar mass of hydrogen is 1.01 grams per mole, which you hopefully remember at this point, but if not, you can always find it in the periodic table. Sulfur, 32.07 grams per mole, and oxygen is 16 grams per mole. Okay, so we multiply as shown in our initial setup, and we'll find our molar mass is 132.2 grams per mole. So then we calculate the number of moles in our substance, and we do that by using this equation, which you should recall from previous lessons. It is very, very important. So the number of moles is simply equal to the mass of the substance divided by the molar mass of the substance. Okay, so we've been told in our setup that we have 15.4 grams of ammonium sulfate, and we calculated in the previous step the molar mass of ammonium sulfate, and so we do the division and we find that we have 0.117 moles of ammonium sulfate. Done. Nice. Okay, for the next step, we need to find the mole ratio. And remember that the mole ratio is just the ratio of reactant to product, or in this case, reactant to reactant. Okay, so in other words, we need to find the ratio that our reactants will combine in. And the way that we do that is just by looking at our balanced equation, which they have given us in this case. There may be some circumstances where you actually have to balance the equation, but we do not have to do that here because it's already done. Okay, since we're only interested in the reactants, we don't have to fool around with the products, so we just ignore those. Okay, and our balanced equation tells us that 1 mole of ammonium sulfate will react with 2 moles of sodium hydroxide. Okay, and that gives us then our mole ratio, which is going to be 1 to 2. Okay, so what that means is that for every 1 mole of ammonium sulfate, we need 2 moles of sodium hydroxide. Okay, so we can convert 1 mole of ammonium sulfate to the correct number of moles of sodium hydroxide just by using this conversion factor. And that conversion factor is simply the ratio that we wrote down from our balanced equation. Okay, so you can see it right here. Okay, when we multiply our conversion factor by the number of moles of ammonium sulfate, we will get the correct number of moles of sodium hydroxide, okay, using our mole ratio. So the conversion factor is simply our mole ratio. Easy. Okay, number 4. Last step, we need to calculate the mass of 0.233 moles of sodium hydroxide, which we calculated in the previous step. And in order to do that, we first need our molar mass. So we go through the same procedure we went through initially, and we find that the molar mass of sodium hydroxide is going to be 40 grams per mole. Okay. Remember, you can get these molar masses directly off the periodic table. Instead of using a unified atomic mass unit, we just use grams per mole. And that is the beauty of Avogadro's number and the mole in general. Okay, last step, we need to calculate a mass here. So we rearranged the equation that I showed you before, where the number of moles is equal to the mass of the substance divided by the molar mass of the substance. And we solve here our equation for M. And then we plug in our values, 0.233 moles times 40 grams per mole. And we will get 9.32 grams of our reactant, which is, in this case, sodium hydroxide. Okay, so perhaps I should be slightly more explicit about that here. Let me know if you have any questions, and I will talk to you guys. There we go. I will talk to you guys soon. Have a great day. Bye.